Suppose this is the horizontal surface. It is frictionless. A trolley of mass m is placed at the surface. So here is a wooden block of weight x Newton, mean the heavy one, and here is another wooden block of same weight x Newton, suppose. One spring is attached at one end and other spring is attached at the other end. Both springs are extended. Spring constant K1. Here the spring constant K2. So extension in this spring is E1. Extension in the spring E2. According to Hooke's law, F is equal to KE. So this side force F1 is equal to K1 E1, and this side force is F2 K2 E2. But trolley is at rest, which is called equilibrium. So due to this equilibrium, left side force F1 is equal to right side force F2. So the resultant force is 0. So we can write K1 E1 is equal to K2 E2. Look, K1 spring, K2 spring mean they are not identical. This extension E1, this extension E2 due to the rest position. K1 E1 is equal to K2 E2. Now, same diagram. These are the positions for the blocks. X Newton both sides. And this is the horizontal surface, which is frictionless. And the trolley is moved towards right. You can move it towards left. Suppose first it was here, now here. It means it is displaced through X centimeter. Then the extension in the left side spring increases. First it was E1, now it increases by X, so it becomes E1 plus X. This spring extension decreases by X, so E2 minus X means no compression. It is still longer than the original length, but the extension decreases. So do remember, there is no compression of the spring this side. It is still longer, greater than the original length. So there is extension, but smaller than the previous value. So this side force is greater than this side. Now the force at the left will be K1 E1 plus X, and the force at the right side will be K2 E2 minus X, and it is held stationary because you are holding it. That's why it's stationary. Otherwise, this force is greater than this force. So your extra force is holding, is balancing. But when the trolley is released, this left side force minus the right side force, it becomes the resultant force. तो दोनों साइडों की forces का जो difference होगा, that is the resultant force. So the left side is K1 E1 plus X minus right side K2 E2 minus X. So this is FR. Now, K1 E1 plus K1X minus K2 E2 and minus minus plus, it is K2X is equal to FR. Okay, now this cancelled with this because both are equal with the negative sign. We have done here K1 E1 equal to K2 E2, so cancelled. Then what is left here? This K1X plus K2X is equal to resultant force. When you will take common X, it is K1 plus K2, the resultant force. So this is the resultant force. Now suppose these two springs are identical. Their spring constant is same, suppose K and K. Then for the identical springs, K1 and K2 both are represented by K, then the resultant force will be K plus K is equal to resultant. So the resultant force in this case will be 2kx. Look, the resultant force Fr is equal to 2kx, but when two springs are non-identical, then it's x bracket k1 plus k2. When this trolley is released, it will oscillate like this, and we have to prove that this oscillation is simple harmonic. So first, the resultant force is equal to x K1 plus K2 when the springs are not identical. According to Newton's second law, this resultant force is Ma. The force is restoring, so minus sign, x is equal to K1 plus K2. So A is equal to minus x K1 plus K2 over M. And we have done that omega square is either G over L or K over M. So this portion, K1 plus K2, is definitely another K. So this K over M is omega square. So we can write A is equal to minus X omega square. Look, K1 plus K2, it will remain K. The quantity will remain same, the bigger value of K. And we can write here where the omega square is K1 plus K2 over M. So omega is equal to under root of K1, K2 over M, mean 2 pi F is equal to K1 plus K2 over M. And finally, here we can write 1 over 2 pi under root K1 plus K2 over M. This is the frequency of the oscillation if it is proved that this trolley is executing simple harmonic motion and its springs are non-identical, but when the springs are identical, then the resultant force is little bit different. It is 2kx. This resultant force MA restoring, so minus MA, so it becomes 2kx. So A becomes minus x 2k over M. Double of the k is also the k, so we can write minus x omega square because omega square is k over M, and this 2k is the larger value of k, so 2k is also k. So here, omega square is equal to 2k over m. So omega is equal to 2k over m under root, mean 2 pi f is equal to 2k over m. And finally here, in this case, we can write 1 over 2 pi 2k over m. Okay, this is example number 3. I repeat this. This is the trolley of mass m, spring constant k1, spring constant k2, right? According to Hooke's law, F is equal to KE. So here extension E1, here E2. So this side force is F1 is equal to K1 E1, and this side is F2 E2. In the equilibrium position, both forces are equal, but when the trolley is displaced towards right through X, this extension increases, this extension decreases. So this side force is greater than this becomes K1 E1 plus X, and this becomes K2 E2 minus X. And the difference of these two forces, left side force minus the right side force, is the resultant force. So this minus this is FR. So K1 plus K1X minus K2X plus K2X, K1, K2, or K1E1 and K2E2 both are equal but opposite cancelled. So this is actually the final shape of the resultant force. But when springs are identical, then this will be the resultant force. Okay, now move to next example, which is example number 4. Of simple harmonic motion. First, we will assume that this is the liquid of uniform density. Practically, it's not possible. So the density of the liquid from bottom to the top is same. Okay, usually bottom pe more dense hota hai, top pe less dense, but we assume it is of uniform density. And we place here a test tube of uniform cross-sectional area. It becomes unstable. It tilts either this side or this side because it is unstable. To make it stable, we will add some sand in it. हम sand डाल देंगे ट्यूब के अंदर. Due to this sand, its center of gravity is shifted down from this position to this position. Now this is the new center of gravity. When the center of the gravity is lowered, according to the O-level physics, stability increases. So it becomes stable. In this position, suppose it is stable. When it is stable, now two forces are acting. One is the weight acting down from the center of the gravity, and other is the reaction, that is the upthrust. And in AS, we have done that the upthrust is equal to density into G into volume of the liquid, which is displaced. Look, the depth of the tube inside the liquid is represented by L, suppose. Then the density of the water, G 9.81, and the volume of the water which is displaced, area into height, L. So upthrust formula becomes rho GAL. In this situation, weight and upthrust both are equal due to equilibrium. So we can write mg is equal to rho GAL, mean weight is equal to rho GAL. Now, when G cancelled both sides, then the mass of the tube along with the sand, it becomes rho AL. The same formula, mass is density into volume. So this is the equilibrium. But we have to oscillate it. For the oscillation, we will exert force to immerse the tube further in the liquid. Suppose extra force is exerted from this position, and then it is inside the liquid by x length more. Mean it is displaced in the liquid by x. So total depth becomes now L plus x. So weight remains same, but the upthrust in this situation increases. So we can write when it is dipped, immersed further in the liquid, no change in the weight, but the upthrust increases. What is the new upthrust? It is rho Ga L plus X mean the total length. Okay, now weight is acting down, thrust is acting up, and there is another force exerted by the object, by the person is F. So two forces are acting down. One is the force, external, weight, and the upthrust nu. So this is the equilibrium. Now, in this situation, but when we will release this force, F is released, then this is released, then upthrust becomes greater than weight. So when upthrust is greater than weight, so definitely there will be a resultant force, and we have to calculate that resultant force, the larger force minus the smaller force. The larger force is the new upthrust, rho G A L plus X minus weight. Now look, weight alone is equal to rho G A L. So rho G A L, then finally rho G A L plus rho G A X minus rho G A L. This cancelled, the resultant force, finally rho G A X. So this is the resultant force which will oscillate the tube up and down in the liquid. So acceleration will be produced. So tube will move up and down. Now we have to prove this up and down motion, this oscillation of the tube in the liquid is simple harmonic motion. So FR rho Gax, resultant force produces acceleration. It is restoring. So rho Gax. So we can write then A is equal to minus X rho G A over M. Now again, two part. This M is the mass which is oscillating, and the mass is rho Ga of the tube plus sand. So we can replace this minus X rho Ga over M rho Al. Now here rho cancelled, A cancelled, so it becomes A is equal to minus X G over L, and we have done already that G over L is omega square, hence proved that A is equal to minus X omega square. So the oscillation of this tube in the water, in the liquid, is simple harmonic motion. But sometimes this equation will be given minus X rho Ga over M, and it will be given, it is tested simple harmonic motion. You don't have to prove, it's already tested. Derive the expression for the frequency of the oscillation. Different angle से question पूछा जाएगा बेटा. This equation will be given, and it is tested, simple harmonic motion, you have to prove frequency relation. So I derive the expression for the frequency. So if it's tested, then it must be obeying minus x omega square. We will compare this and this equation. So a minus x, it means this portion is omega square. Then we will write omega square is equal to rho g over m, rho ga over m. Then omega will be equal to rho ga over m under root, and then omega is 2 pi f under root rho ga over m. So f is equal to 1 over 2 pi under root rho ga over m. So this is the formula for the frequency. And similarly, you can write time period 2 pi under root of m divided by rho ga. M is the mass of the tube with the sun, A is the cross-sectional area of the tube, G is 9.81, and this density is the density of the liquid. Next example. Now, example number 5. Suppose we have this U-shaped tube, and its cross-sectional area is uniform, and it is represented by capital A. Incompressed liquid is poured in it. The height of this liquid, both sides will be same, because at the both ends, same atmospheric pressure is exerted. So suppose the one side height is h, then other side height is also h. So what is the total length of the column of liquid? It is L plus L. It becomes 2H. This side length, this side length. So L represented by H, so it's 2H. Now, what is the total mass or weight of this liquid? The mass is density multiplied by volume. So the density is rho. Volume is area into height. So the total height is 2H. You can write L, you can write X, but 2 times, one side, other side. Now, what is the total weight of this liquid is mg, mean it is 2 times rho AH into G. So this is the mass and the weight of this liquid. Now, extra pressure is exerted over here. So here, the pressure is high, and here the pressure is low. So due to the difference of the pressure, this liquid will move, this liquid move down, and this liquid will move up. When both side pressure become equal, then it stops. Suppose this level stops here. How many boxes? 1 and 2. And this level reaches here. So this is now filled with the water, and this is empty from the water. No water here. If this level of the water rises by x, then this level of the water falls by the same height x. So what is the difference between lower level and the upper level of the water from this to this? It becomes 2x. And this 2x height water is known as displaced water, which is displaced from its level. So the mass of the displaced water is equal to rho GA into 2x, because sorry, this is not G, because the density into volume. So it is density multiplied by area into X, just the mass. Now, what is the weight of this displaced liquid? It is mg. Now mg will come. So rho a 2x into g, mean it becomes 2 rho a x g. This is the weight of the displaced liquid. Okay, when this extra pressure is released, mean the pressure exerted above the atmospheric pressure is released, then again both side pressure becomes equal, which is atmospheric. So this displaced liquid will exert unbalanced force. So we will write here the resultant force Fr after releasing the extra pressure is equal to the weight of displaced liquid. So what is the displaced liquid weight? This is the weight. क्योंकि ये रह गया था. Now, this is equal to the resultant force. So we can write resultant force is equal to 2 rho A x and g. Now this displaced liquid will exert resultant force, and due to this resultant force, whole liquid in the tube will oscillate left, right. So this is unbalanced. It produces acceleration in the whole liquid. It is the restoring force. So minus, so 2 rho AXG. And remember, this acceleration is produced in the whole liquid. And what is the mass of the whole liquid? We have done here. Here is the mass of the whole liquid before oscillation, rho A2H. So we can write 2 rho A H acceleration with minus sign 2 rho A X and G. Now rho cancelled, A cancelled, 2 cancelled. So we can write A is equal to minus X G over H. H can be replaced with the L length. So we can write here A is equal to minus X G over L. So G over L is also proved omega square. Hence, the oscillation of the liquid in the tube is minus X omega square. So it is now tested simple harmonic motion. Okay, again, if the question is resultant force is given, this one, and then from this equation, it is written like this: A is equal to minus X 2 rho AG divided by M. Okay, this M is not replaced by rho H, it is written as M. Then it is tested simple harmonic motion. Derive the expression for the frequency of the oscillation of the liquid. So we will compare this equation with this, minus compared, X compared. So this omega square is this. So we will write here omega square is equal to 2 rho AG over M. So omega is equal to 2 rho AG over M. Now F frequency will be 1 over 2 pi under root 2 rho AG over M. So this is the answer for the frequency. Now similar to the previous one, this one here. Yes.